So welcome to this session. Today we will learn about quick sort. What is a quick sort? Okay. This sorting algorithm uses the idea of divide and conquer. So it will divide list, it will divide problem, and then we will find this divided problem, the solution of this divided problem. And again, the solutions will be combined, and eventually we will find our solution of a bigger problem. Okay, so you can see that if it finds the element called pivot, which divides the array into two equal halves in such a way that the elements in the left half are smaller than the pivot and elements in the right half are greater than the pivot. Then we recursively perform three steps. First step is bring the pivot to its appropriate position such that left of the pivot is smaller and right is greater. So every element to the left of the pivot is smaller than the pivot element, and every element to the right of pivot is greater than the pivot element. And these steps we need to perform it recursively. Then we'll call quick sort for the left part again. Then we will call quick sort for the right part again. So this is quick sort. Then pivot is selected at the last element. Okay, we are doing like this way. So there is this algorithm that is called heart of quick sort. This algorithm is called heart of quick sort, and this is called partition. Okay, so there are some counter variables that will count the index of smaller element and the loop variable j. So j will run the loop, and index is a smaller element. So we can see there are three things that should be considered while performing this quick sort or partition procedure. We need to test a condition. There is a test condition, that is, if any element is less than pivot element, then what should be done, and then what actions to be performed, and then the values of variables. We'll see all of them one by one. So let's see those. So we have taken the last element as a pivot element. Now we start the loop with the initial value of pivot, that is 70. And next thing is in pass one. In pass one, you can see we'll compare pivot element with the first element, that is 10. At the bottom, you can see 10 is less than 7, which is true. And the test condition is a of j. J is starting from j, you can see is 0, 0th element at index 0, and I is -1. I is 1 lesser than the jth element. Okay, so that is -1. So if we are starting j from 0, I will be -1. And test condition is that a of j, whatever is the element, should be less than pivot. If it is not less than pivot, then we will not perform this action. Okay, so what is this action? If it is true, I will be incremented by 1. So here, if I was -1, after increment, it will become 0. After increment, it will become 0, and we'll swap whatever the element is at a of 0 position and a of j position. So we will swap a of I and a of j. So this is the simple condition. So this is how it will be done, and we can see all the passes here now. I's value is 0, then pass 2, j will increment it, and 80 will be compared with 70, which is false. No action will be taken. Now in pass 3, you can see j is 2, and 30 will be compared with 70, which is true. I will be incremented, and We'll swap A of I and A of J. You can see from here. In pass 4, J will be incremented. Now 90 will be compared with 70. And you can see all these iterations. And we'll go to the last iteration where our 70 will come at its appropriate position. So at the end of 7 passes, what will happen? Will come to the position where our element will be at the at its appropriate position before after sorting. So after sorting, 70's correct position is this, and all the elements to the left are smaller than 70, and all the elements to the right are greater than 70. And we'll apply quick sort from 10 to 50, and we'll apply quick sort from 90 to 80 again. This is a left sublist, and this one is a right sublist. And if we apply it again, the last element will be 50. And after doing that, again, there will be a left sublist, and that is from 10 to 40. Then last element will be 40 because these are already sorted. So there will be lesser comparisons, lesser movements. So next element is 30, so on. And in the right sublist, 90 and 80 are there, and these will get sorted again. 90 and 80 are there. These will get sorted by using the quick sort again. So these will be replaced. Array is now sorted. We'll see its code now. So there is a high value of partition and there is a low value of partition. High means from where we are starting the array, and low means it is before the starting position. And there is a element called pivot element. In pivot element, we are storing the last element of array, that is a high element. Okay. Then I is low minus 1. Low is the starting point of the array. And we'll start the loop from low to high minus 1 because we are starting from 0, and we'll increment j by 1. And if a of j is less than pivot element, then we'll increment I by 1 and then the swap the a and a of I and a of j. And after we are done with this loop, if condition and this for loop, then we'll swap the last element with its appropriate position and then return I plus 1. And after returning, we will call quick sort again. So after this partition procedure, after we have called it once, then only one element will get its appropriate position, and there will be two sublists, left sublist and right sublist. So we need to call quicksort again for those left sublist and right sublists. So we'll call recursively this quicksort again from low to partition minus whatever the element uh, we will get returned from here, the index we will get returned from here. According to that, we will divide these two lists, left sublist and right sublist. So this is how our program will be done. Now we will see its program in C++. So we'll see its program now, quicksort's program. So we'll start with the new file here in our compiler, and we can start writing by comment, which is the name of the program. That is quick sort. And we'll also save this file first. I'll write its name as QS1, let's say. and dot cpp. This is the name of my program. Then I'll write my header files. These are hash include conio.h and hash include iostream.h. These are my header files. Now we'll start from the main function, because whenever you compile the program, it always looks for the main function. So we'll start from the main function. That is our driver code. So here I'm going to write our main function. And inside main function, I need to declare my array. Before that, I can also write clear screen, and then I'll declare my array. You can do it dynamically. So that's your task to do. You can do it, you can declare and insert the elements of array dynamically. I'm doing it statically. So these are the elements, let's say 10, then we have 7, then we have 8, and then let's say 19, and then we have 1, and we have 15. These are our elements. We want to apply quick sort technique to sort these elements. Okay, so here we are writing our termination symbol, then we'll count how many elements are there. And in dynamic way, if we are declaring the elements in dynamic way, we already know the n. We need not to calculate this. So we can do like this there. By doing this way, you can learn that how company we work in the company environment. So we'll make different modules of every function. We'll make different modules of every function. The main function is also a function, so we'll make a different module of it. And this is our size of array. Then we'll divide it with the size of one element. That we are doing in our other programs as well. So here we'll divide it with the first element. Then we will call quicksort. Quicksort for this array, the same array that we have used, we'll pass it to the quicksort, and then we need a starting point, that is 0th index. Then we know that ending index will be number of elements minus 1, because we are starting from 0 again. Okay, then we have we'll display the sorted array. We'll simply display the sorted array. So now we can write cout and sorted array. We can give a message sorted array is, and in next line it will get printed. So for printing, we'll also create a function, and we can write get ch here to get character until we are done with our output. So that is all. So let me write here. Okay, I've missed we'll write print array which array, this one, and with this size. Okay, so these are the functions that we have called. We need to create these functions. So first of all, we will be creating this function, that is our quick sort function. Let's create it. So we'll create quick sort very quickly now, and after that we'll create other functions. So what is our quick sort? So we'll write void, then quick sort, name of the function, and then we'll take the same variables This is, we are taking an array, and then there is a low index, that is the index of the starting point, and then we have the high index that will represent the ending point in an array, the last element in an array. Then we'll start this function and write the compound statements, and after writing the compound statements I will give the exit condition here from the recursion, that is low should be less than high. So index, whenever we are reducing the list, low should not be low should be less than high. It should not get equals to high or greater than high. So it should not get equals to high. So that is our concern here. There the recursion will stop, and we need to call partition here. In partition, I'll write pi equals to, we'll call another function called partition. You can name it anything that you want, but it is the appropriate name. So partition will be called here, and for what values? For the whole array that we have seen from low to high, from low to high. So this partition will what is pi here? Pi is the partitioning index. App is now at the right place. After calling this, the element at last position will be at its correct position after calling this. Then there will be two separate lists created for after partition. So after partition, there will be two separate lists, and quicksort will be called again for those. So quicksort will be called again for ARR. Now because it is, if it is the left list, then low will remain same. The high will change. It will to the partition minus one. Partition minus one. So separately sort elements before partition and after partition. So this is before partition and after partition. So we'll call one more quick sort for what? For ARR, and for here low will change because it will be pi plus 1, and high will remain same in this list. So this is our quick sort function. This is our quick sort function. Now we need to declare the partition function. So we'll see what is partition function. So let me write it down. So here we'll start writing partition, but it will return something. Okay, so it will have a return type because it is returning us the position of pivot after the first pass, after the 7 passes that we have seen in the previous example. Okay, so the pivot element will be at its correct position, so that will be returned here. So we are taking its data type, its return type as integer, and the name of the program is, name of the module is partition, and we'll write same things here, ARR and int low, then int high. Now these are the arguments that will be used in partition program, and I'll write compound statements here. And before writing it, I already know that I need to use a pivot element. So what is our pivot element? Pivot element is equals to, pivot element is equals to ARR array of high, last element. ARR of high. Okay, then we have a for loop here, and before writing the for loop, we need to take the index I, that is I equals to low minus 1. So that is the index I. Now we'll take a for loop for, and we'll start it from j from low, and then we'll write j less than equals to high. That we have already seen in the our video. It should be less than equals to high. And after writing it, okay, it should be less than equals to high minus 1, because we are not including the pivot element in it. So that's why it's high minus 1. Then we'll write j plus plus, and after writing it, I'll put the compound statements again, and we need to check condition here. What is our condition? That is ARR of j should be less than or equals to pivot element. Okay, it should be less than or equals to pivot element. And in that, if the condition is true, we are going to increment I by 1. We are going to increment I by 1, that is I plus plus, and also we are going to swap. So we are going to swap A of I with, we are going to swap A of I with A of j. It is not A actually, it is ARR. ARR of I with ARR of j. So these will be swapped. A swap will not be used directly in C++. So you can do swapping here, or we can create a swap function also. In order to pass the elements of array, I have to pass the address of that element. So I'll write address of operator alongside with it. Okay. So I'll create a swap function again at the top after we are done with this partition function. So we have written for the if condition, then after writing the for condition, after for condition, after sorry for loop, we'll have to write the swapping swap of, we'll call the same function again but for different set of values. What are those values? So we'll pass address of ARR of I plus 1, I plus 1, and address of ARR of high. Last element will be swapped with I plus 1 element. So swap function we are yet to create. Okay, then we will return, because we are returning something here, so that's why we have taken the return type of the function, that is int. So it is a integer value that will be returned. So we are done with our partition function. Now we will write our swap function and print function. So for writing swap function, I'll take void swap, and then I will write here int, and this is how we call the elements by using pointer of array. Int star b. There are two elements that needs to be swapped. So how can they be swapped? You can do the same thing in the function as well, in the same function. There is no problem in that. So I'll take a simple variable here, temporary variable, and I'll store the value of first argument, that is a, in this. And then in a, we will be storing whatever there is a value of B, and in B will be storing whatever there is stored in T. Okay, this is how we do swapping with the element of array. Elements of array can be fetched by pointers. So these are the pointers in the function. This is how we pass the element of array in the function. Now only one thing is left, that is this our print array. So we want to print our array. Here we'll create a function void print array. We'll create a function void print array, and for printing we'll use a for loop and array itself. So that is our array. This is int arr of this, and then we have the size of the array, that is n already passed when we have called this function at the in the main function. And here are the compound statements, and now I'll write int I, put a semicolon here, and then I can write for I equals to 0. We are starting the index from 0. Then we have to write I less than size of the array and I plus plus. And after it, I have to write cout arr of I, and I'll give some spaces in each element. And after printing, I can also print a new line. Okay, so this is our code. Let's see if it works or not. So we'll compile this one. There is no error in it. And if we run it, we can see our elements are sorted. So this is about quick sort. This is how we do quick sort in C++. Thank you.